In question number 2, we're able to use our calculator and we're given a table displaying values of x and g of x. Let's read the prompt and see if we can figure out what this question is asking us to do. So we have here that selected values of a twice differentiable function g are given in the table above. And then what we want to answer is this question: what is the value of the integral from 0 to 3 of g prime of x cosine squared 2g of x plus 1? Goodness gracious. When I look at this problem, it looks kind of difficult at first, but we need to break this apart. So first we've got a g prime of x, then we've got a cosine squared, and then on the inside of the cosine squared, we've got 2g of x plus 1. It would be great if we found the derivative of 2 times g of x plus 1, and that might cancel with the g prime of x. So in this case, what I'm going to do is I'm going to choose an expression for u to be the inside of the cosine squared, which is going to be 2 g of x plus 1. Let's find the derivative with respect to x of each side. So we've got 2 as our coefficient times g prime of x. The derivative of 1 is 0, so you don't need that. If we multiply by dx on each side and also divide by 2 g prime of x, we wind up with du over 2 times g prime of x is equal to dx. It's now time to take the expression for our integral and also our lower and upper limit, and that's this guy right here. And we're going to switch everything out in terms of u. We're actually going to have to work with the 0 and the 3 here. Let's do that in a second, though. So if we work with our integrand, which is the expression inside the integral there, we've got now cosine squared of u. Remember we made u 2 times g of x plus 1. And then dx right here is equal to du over 2 times g prime of x. And something interesting is going to happen here. So the g prime of x will cancel. We can actually bring the 1/2 out to the front. That's this piece right here. And then we'll wind up with cosine squared of u du. Now we also need to work with our upper and lower limits. So let's work with the upper limit first. So to figure out the new upper limit, we're going to take the x value, which is 3, and just sub it in to our expression for u, which is right here. Then we'll have everything in terms of u. You can do this early on or a little bit later. It's up to you. When you write those down, though, what you want to do is you want to make sure that when you have an integrand and a differential with u in it, you make those upper and lower limits with respect to u as well. So we'll type this in. We'll go 2 times g of 3 here. 3 is your old or your previous or your x value for your upper limit. And that's going to be plus 1. So we'll go up to the table, and g at 3 is right here. That's negative 2. So this will be 2 times negative 2 plus 1. That should be a 1 over here, which is negative 4 plus 1, or negative 3. So we can replace that here in the upper limit with negative 3. For the lower limit, we're going to do the same thing, except now this time the lower limit is 0, I think. Let me just make sure it is. So we'll do g of 0 plus 1. Try to figure out what that is. G at 0 here is 5. So that'll be 2 times 5 plus 1, which is 11. So that's our new lower limit. Now, don't worry if the lower limit is bigger than or has a greater value than the upper limit. Our calculator will be able to deal with that just fine. So the next step here is to just type this into your calculator. And so we'll type in 1/2, and then we'll go to that math number 9. And then if you have the newer version, you'll have a little box here, and then a little box here. And then you'll do 11 in the lower limit, negative 3 here. You can do the cosine squared of u du, but in reality, you're probably just going to want to hit the X button here. I wouldn't actually write that down, though. That would be incorrect. So to type this in your calculator, I'll put don't write on exam, exclamation part, this part right here. You're just going to write, and you wouldn't, well, I guess it wouldn't matter. It's a multiple choice question. We're kind of going free response here. You could just do this. You could just do parenthesis, cosine of u, close parenthesis, squared, and then there's going to be a little box here too, and then you're going to type in, oops, that's going to be an x. And then you're just going to type in x here as well. So the variable actually doesn't matter when you type it in your calculator. You just need these guys to be the same right here. And then you'll get that approximate value when you type it in. You should get about negative 3.464 when you type this whole thing in. Notice I've got one set enclosing the x here, and then I have another set enclosing the entire cosine of x. Then I want to square that, and in your calculator, you'll automatically have this guy right here. So we'll want to put an extra set. So you're going to need 3 left and 3 right to type this in correctly. So that's about negative 3.464. If you were on the free response, then you would want to record that answer, and you wouldn't want to write any of this down. You don't want to write down what you're typing in your calculator. You can just go ahead and type it in and get that correct answer. Of course, the correct answer then for this one is a B.